Okay, welcome back to the Algebra 2 final exam review. In this video, we're going to cover our last section, section 20. So, I want to say that this section is not explicitly covered on, it actually is not covered at all on your exam. So, this really is an optional section to learn. However, I do recommend learning it because especially if you're going into pre-cal next year, we're definitely going to work with stuff like this. So this is kind of a primer for that. And also, if you watch the video and do the notes and write down solutions and all that, you still get extra half an extra point on your final exam. So that's kind of a win-win if you learn this now. So let's just get it started with I guess a primer here. So if we have a over b times c over d, if we're multiplying two fractions together, all we have to do is multiply the numerators together, and we get AC, and we multiply the denominators together, and we get B times D. And so, with that in mind, what if we have something like A over B times C over A? Well, if we multiply these two together, we have A times C over B times A. And from our previous video, we saw that if we have common factors in a fraction, we can cancel them out. And in this case, we would be left with C over B because the A's cancel out. So, in a nutshell, if we have common factors, even in different fractions, so if we have an A over here and an A over here, even though this A is in the left fraction for the numerator and in the denominator A is in the right fraction, they still cancel out. We can cancel out these A's. We get C over B, and that's what we have over here. So we're going to use that fact to basically just expand upon this last section that we did. So let's look at number 265. So for 265, we have 1 over n minus 7 times n squared minus 2n minus 35 all over 5. So the first thing we want to do is check if the left fraction is factored. And it looks like it is. We have 1 and n minus 7. We can't do anything with that. However, we do have n squared minus 2n minus 35. We want to find two numbers that multiply to 35 but add up to negative 2. And so our two numbers there are, let's see, that would be negative 7 and positive 5. So we can rewrite this whole thing as 1 over n minus 7 times n minus 7 times n plus 5. And then all of this is over 5. And now notice that we have n minus 7 and n minus 7 as, in the numerator and the denominator here. So they still cancel out. And what we're left with is just 1 times n plus 5, which is just n plus 5, all over just 5. So we have n plus 5 over 5. And like the previous video, we want to find our excluded values. So we just want to find all the stuff that can't be equal to 0. Well, n minus 7 can't be equal to 0, which means that n can't be equal to 7. Or we can basically just flip this sign here. So n minus 7 can't be equal to 0, so n can't be equal to 7. And so we say that n can't be equal to 7, and there we go. What about number 266? We have b minus 2 over b minus 5 times 3b squared plus 27b all over b squared plus 7b minus 18. Okay, so we've got a lot going on here. However, for the left fraction, we have b minus 2 over b minus 5. That's factored already. We can't do anything with that. But let's see what we can do with this fraction over here. I'm just going to rewrite the b minus 2 over b minus 5 because we can't simplify it. But what about the numerator on the fraction on the right? Well, it's the greatest common factor between 3 and 27. Well, that would be 3. And the greatest common factor between b squared and b is b. So 3b times what gives us 3b squared? That would be b. And 3b times what gives us 27b? That would be 9. So 3b times b plus 9 is equal to 3b squared plus 27b. Now, what about the bottom? Well, we have b squared plus 7b minus 18. We want to find two numbers that multiply to negative 18 but add up to positive 7. That would be positive 9 and negative 2. So we have b plus 9 times b minus 2. And now that everything is factored, we want to cancel out everything that we can. So we have a pair of b plus 9s, and we have a pair of b minus 2s. And all that leaves us with is 3b over b minus 5. And now we just want to find all of our excluded values. So we have to do excluded values for every single one of these. So for all of this stuff here, we have excluded values. B can't be equal, just flip the sign here, to 5. B can't be equal to, flip the sign, negative 9. And b can't be equal to this minus 2, so flip the sign, positive 2. So b can't be any of these numbers. And so we can put that in a compact notation of saying that b can't be an element of the set. And it doesn't matter what order you write them. So you have 5, negative 9, or 2. And we see that this is clearly a shorter way to write all of this. And that's why I introduced this notation in the last video, because some of these we're going to have several excluded values. But this is our final answer. What about number 267? We have 8 minus b divided by 9 times 2b minus 20 divided by b squared minus 18b plus 80. Okay, well, can't do anything with 8 minus b or 9, so we have 8 minus b over 9. And now let's check with 2b minus 20. Well, let's see, that's going to be greatest common factor between 2 and negative 20. It's going to be 2, and we can't factor out a b because we don't have any b's in this term on the right. So we can factor out the 2, and that leaves us with 2 times what gives us 2b? 2 times b. And then 2 times what gives us negative 20? That would be negative 10. All right. What about over here? So we have b squared minus 18b plus 80. What are two numbers that multiply to 80 but add up to negative 18? Well, that would be negative 8 and negative 10. So we have b minus 8 times b minus 10. And so we have the b minus 10s. They cancel. But we have this 8 minus b and this b minus 8. Those look kind of similar. and that should tell us that they actually might cancel. And what you can do with this one, this 8 minus b, is you can rewrite this is negative b plus 8. You can just switch these numbers, or switch these two values around. That's because of the commutative property. And what if we factor out a negative 1? If we factor out a negative 1, this is now negative b minus 8. So 8 minus b is the same thing as negative b minus 8. So it turns out that we can cancel the 8 minus b and the b minus 8 as long as we put a negative 1 right here. And now we don't have any b minus 10s, we don't have any b minus 8s. All we have is negative 1 times 2, which is negative 2, and a 9 on the bottom. So we have negative 2 over 9. And now we just need to state our excluded values. So we only care about the values that would make us divide by 0. So that's why we never worry about anything in the numerator. It doesn't matter what numbers we plug in for the top. It's the numbers in the bottom that we care about because we don't want to divide by 0. But from this one, we see that b can't be equal to 8, and b can't be equal to 10. All we have to do is flip these two signs here. And so we say that this is all equal to negative 2 over 9, with the condition that b can't be equal to 8 or 10. And so this is our final answer. What about for number 268? We have 3k plus 18 divided by k squared plus 15k plus 54 times k plus 9 divided by k plus 2. So k plus 9 and k plus 2, those can't be factored any further. So that's fine. We'll leave those as is. But what about the left fraction here? We have 3k plus 18. Well, 3k plus 18, the greatest common factor between 3 and 18 is 3. And we can't factor out a k because this 18 doesn't have a k with it. So 3 times what gives us 3k? Well, 3 times k. And then 3 times what gives us 18? That would be 6. And this is all going to be divided by whatever we factor this the denominator for. We try to find two numbers that multiply to 54 but add up to 15. Two numbers that do that would be 9 and 6. So we have k plus 9 and k plus 6. And now for the other fraction, we just have the k plus 9 and k plus 2. So we have a common factor of k plus 6 right here. So k plus 6, k plus 6, and then the k plus 9 and k plus 9. So those cancel as well. All that leaves us with is a 3 in the numerator and a k plus 2 in the denominator. But what about our excluded values? Well, from here, k can't be equal to negative 9. Just got to flip the sign here. And we'll flip the signs on this positive 6 and this positive 2 here. That means that k won't be able to equal negative 6, and k can't be equal to negative 2. And so we have this condition that, well, all of this is just equal to 3 over k plus 2, but k can't be an element of negative 9, and it looks like I ran out of room there, but negative 6 and negative 2. And so That is our final answer. Let's look at the next one. So the next one we have is number 269. We have 2r cubed minus 20r squared divided by r plus 3 times 1 over r minus 10. So the fraction on the right can't be factored anymore, so we can leave that as is. But what about the fraction on the left? Well, the r plus 3 is already factored, so really we only have to worry about this numerator over here. So, greatest common factor between 2 and negative 20 is going to be 2. Ooh. And we also need to check for our variables. The greatest common factor between r squared and r cubed and r squared is r squared. And so now we have to ask ourselves, well, 2r squared times what gives us 2r cubed? Well, if we multiply that by r, we'll have 2r cubed. And then 2r squared times what gives us negative 20r squared? That would be negative 10. And now we have our r plus 3 times 1 over r minus 10. Well, we have these common factors of r minus 10 and r minus 10. So those cancel. But because everything is factored, we can't factor anything else. Or we can't cancel anything else. We have 2r squared times 1. So we have 2r squared over r plus 3. And so now we just need to make sure we're not dividing by 0. Well, from this plus 3 and this minus 10, r can't be equal to negative 3. And over here for the plus 10, r can't be equal to positive 10. So we say that this is our final answer. All of this simplifies to this. But r cannot be an element of negative 3, 10. And so this is our final answer. What about number 270? We have p squared plus 4p minus 32 divided by 10p cubed plus 80p squared times 10p squared divided by 6. So, a lot going on here. So let's get to it. First, let's factor the numerator and the fraction on the left. So we want to find two numbers that multiply to negative 32 but add up to positive 4. Those numbers are going to be positive 8 and negative 4. So we can write this as p plus 8 times p, not plus, minus 4. This is all divided by whatever we can factor this to be. Well, the greatest common factor between 10 and 80 is 10. And the greatest common factor between p cubed and p squared is p squared. So now we want to figure out 10p squared times what gives us 10p cubed. Well, if we multiply this by p, we now have 10p squared times p. We have our 10. We have our p squared times p, which is p cubed, so we know that we have the right thing here. And now we ask ourselves, what is 10p squared times what gives us 80p squared? Well, we already have the p squared. So now we just need to multiply 10 times some number to get 80, and that's going to be positive 8. Now on the other side, we have a 10p squared already, and we have a 6. So 10p squared, and then over 6, So now we just want to cancel all of our common factors. The p plus 8s go away, and the 10p squareds go away. And that means all we have left is this p minus 4 divided by 6. And now we just want to check for our excluded values. So, taking all of this, because we only care about the bottom, we don't want to divide by 0, we have that 10p squared can't be equal to 0. Dividing by 10 on both sides of that, that means that p squared can't be equal to 0. And if we revert back all the way to our first section on this review, to cancel out the square, we take the square root of both sides. We get p cannot be equal to plus or minus the square root of 0. Well, fortunately, all of this is still just 0. So p can't be equal to 0. And then over here, this just gives us that p can't be equal to negative 8. All we have to do is flip that sign. So p cannot be an element of 0 or negative 8. And so this is our final answer. All right, so we are now down to the final, subsection of the final section. What happens when we do division? So, turns out the division is a little bit different. What if we have a over b divided by c over d? So, what this means is that we have a over b divided by c over d, like this. So, big fraction bar between these two smaller fractions. Well, if we want to get rid of this compound fraction here, what we want to do is multiply both the top and bottom. It has to be by the same thing on both the top or bottom so that we can keep the same value for our fraction. But we multiply the bottom by d over c. But we have to do that to the top as well. That's also times d over c. Well, c and c cancel here, so that goes away. But so does d and d, which means that all of that down there is equal to 1. And dividing by 1 means that, well, we have whatever it is that we are working with in the numerator. So if we have anything divided by 1, it is equal to whatever that thing was. So anything divided by 1 is itself. And since we're dividing by 1 down here, really this is just equal to a over b times d over c. So notice what happened between here and here. We still have a over b in the front, but if we want to switch this division sign out for multiplication, all we have to do is flip this fraction. This one is c over d, but this one is flipped and we have d over c. So, in a nutshell, a over b divided by c over d is equal to a over b times d over c. So, we're going to use this property of flipping our fractions to solve the 6 remaining problems that we have. So I think we'll have enough room for number 271. So for number 271, we have n plus 7 divided by n squared plus 4n minus 21 divided by 1 over 4n minus 12. So to convert this into multiplication, we just have to flip this fraction on the right. So this is equal to n plus 7 divided by n squared plus 4n minus 21 times 4n minus 12 divided by 1. So again, we switched this division symbol for multiplication, and then we flipped the fraction on the right. And now we proceed like normal. So I'm going to start down here, since a wildcat drawing appeared. And we have n plus 7. And now we want to factor the n squared plus 4n minus 21. We want to find two numbers that multiply to negative 21 but add up to positive 4. Well, the two numbers that can do that are positive 7 and negative 3. So we have n plus 7 times n minus 3. And we're going to multiply that with whatever this factors out to be. Well, the greatest common factor between 4 and 12 is 4. And we can't factor out a variable because this doesn't have a variable over here. So 4 times what gives us 4n? Well, 4 times n gives us 4n. And 4 times what gives us negative 12? 4 times negative 3 gives us negative 12. So now we have 4 times n minus 3 divided by 1. Canceling our common factors, we have an n plus 7 and an n plus 7. And we have an n minus 3 and an n minus 3. All that leaves us with is 4 over 1. And anything divided by 1 is itself, so this is just equal to 4. And now we just want to figure out what our excluded values are. N can't be equal to negative 7, because this is a positive 7 here. And n can't be equal to positive 3, because this is a negative 3 here. And so we say that n can't be an element of the set negative 7, 3. Of course, that's not entirely necessary because, well, and actually it is necessary. Because even though this is always 4, again, this has to be, if we're saying that this is equal to this, we can't plug in negative 7 or 3 over here to make that equal to 4. So actually, yeah, we do have to say that despite there's no n to plug in over here, n still cannot be equal to negative 7 or 3. So this is our final answer. All right, let's look at number 272. We have n plus 9 divided by n plus 6 divided by 2n squared minus 16n divided by n squared minus 2n minus 48. So remember, to make this multiplication, we have to flip this fraction here. So we say this is equal to n plus 9 divided by n plus 6 times, flipping this fraction, n squared minus 2n minus 48 divided by 2n squared minus 16n. And now, let's factor this fraction over here. So the n plus 9 over n plus 6 is fine. We can leave that as is. However, let's find two numbers that multiply to negative 48, but add up to negative 2. So two numbers that do that, we have the numbers 6 and 8, those multiply to 48. And if 8 is negative and 6 is positive, we'll get the negative 2. So n minus 8, n plus 6. And now this is all over 2n squared minus 16n. Well, what's the greatest common factor between 2 and 16? That would be 2. And the greatest common factor between n squared and n is n. So now we need to figure out 2n times what gives us 2n squared minus 16n. And so 2n times what gives us 2n squared? Well, 2n times n gives us 2n squared. And then we ask ourselves, what is 2n times what gives us negative 16n? That would be negative 8, because 2n times negative 8 is negative 16n. So everything is factored. We just want to cancel our common factors now. Well, immediately I see the negative n minus 8s cancel, and the n plus 6s cancel. So that means the only things that we have left over are n plus 9 divided by 2n. And now we just need to figure out what our excluded values are. So from over here, we have n can't be equal to negative 6. From here, we have that n can't be equal to positive 8. And from here, we have that 2n can't be equal to 0. And dividing by 2 on both sides, n can't be equal to 0. So our excluded values are that n can't be an element of the set negative 6, 0, and positive 8. And so this is our final answer. What about with 273? 273, we have 5x divided by x plus 4 divided by 10x minus 50 divided by x squared minus x minus 20. So, first, let's flip these fractions. This is going to be equal to 5x divided by x plus 4 times x squared minus x minus 20 divided by 10x minus 50. And so 5x is factored, x plus 4 is factored. Now let's factor this fraction here on the right. So we still have our 5x over x plus 4, but we find two numbers that multiply to negative 20 but add up to negative 1. Those two numbers would be negative 5 and positive 4. So x minus 5 times x plus 4. And then we find the greatest common factor between 10 and 50, which is 10. And we can't factor out an x because we don't have an x next to the 50. So 10 times what gives us 10x? That would be x. And then 10 times what gives us negative 50? That would be minus 5. So now that everything is factored, let's cancel common terms. We have x plus 4s, x minus 5s, and then we have a 5 over 10. Well, 5 over 10 is the same thing as 1/2. So when we multiply 1/2 times x, this is just equal to x over 2. And now we just have to figure out our excluded values. So from right here, let's see, we say that x is not going to be an element of flipping the sign here, x cannot be negative 4, and flipping the sign here, x cannot be equal to positive 5. And so this is our final answer. For number 274, we have 10r plus 100 over r plus 10. And this is divided by 7r divided by 10. So, flipping this fraction and changing this to a multiplication sign, we have 10r plus 100 divided by r plus 10 times 10 over 7r. So 10 and 7r are already factored, but 10r plus 100, we can pull out a common factor of 10. So we have 10, and then 10 times what gives us 10r? Well, that would be r. And then 10 times what gives us 100? That would be 10. Divided by r plus 10, and getting low on space there, but we have 10 over 7r. And so the r plus 10s cancel, and all we have left over is 10 times 10, which is 100, and then all over 7r. So 7r. And what are our excluded values? Well, we can't divide by 0, so r can't be equal to negative 10. And 7r can't be equal to 0, so r can't be equal to 0. And so those are our two excluded values, and that is our final answer. All right. And now we only have 2 more questions, so we're almost there. If you've made it this far, thank you for watching all of this. It has taken me a long time to do all of these videos, so I really appreciate you watching if you've made it this far. So we have 275, we have 1 over r minus 7 divided by r plus 10 over r squared minus 100. So let's flip this fraction so that we can change this to a multiplication sign. This is 1 over r minus 7 times r squared minus 100 over r plus 10. Well, using our difference of squares formula, we still have 1 over r minus 7. And we can set this up as r minus a number times r plus a number. And we just want to take the square root of 100. Square root of 100 is 10. So we have r minus 10 times r plus 10. And now this is all over r plus 10. Well, we can cancel the r plus 10s, but looks like we still have r minus 10 and r minus 7. We can't do anything more with that. So 1 times r minus 10 is r minus 10, and that's divided by r minus 7. So we have this, and now what are our excluded values? Well, r can't be equal to positive 7, and r can't be equal to negative 10. And so this is our final answer. And now for the last one, we have 276. So we have a plus 3 divided by 10a squared minus 90a divided by a plus 3 divided by a minus 9. So first, let's flip this fraction so we can change this to multiplication. We have a plus 3 divided by 10a squared minus 90a times a minus 9 divided by a plus 3. So first, let's factor the 10a squared minus 90a. So we have the a plus 3. And now, the greatest common factor between 10 and 90 is 10. And the greatest common factor between a squared and a is a. So that just leaves us, we have 10a times what gives us 10a squared? Well, 10a times a gives us 10a squared. And then 10a times what gives us negative 90a? Well, minus 9. So 10a times negative 9 is negative 90a. We're going to multiply this with a minus 9 over a plus 3. And canceling our common terms, we have a plus 3, and our a minus 9s cancel. Anytime you run out of stuff in the numerator to write, you can always factor out a 1. And so this is just 1 over 10a. And our excluded values are that A cannot be an element of the set from over here. A can't be equal to 0. So A can't be equal to 0. A can't be equal to 9. Let's flip the sign there. And then A can't be equal to negative 3. So, there we go. That is our final answer, and that completes the final exam review. So, if you've watched all of these videos, thank you again for doing that. This took a lot of time on my hand. I think about, I don't know, just estimating somewhere between 8 and 10 hours to film all of this. So, again, thank you for watching all of this, and if you've made it this far, I don't know, let me know somehow. Um, but that's all I've got for you. So, best of luck on your final exam, and I will see you on Tuesday.